Hi students, welcome to another video on control systems. In this video we will focus on root locus of system, specifically root locus of complex poles and zeros. Okay, these are the prerequisites. Now let us proceed and try to find first. Now we just focus on how do we find angle of departure of a system having complex poles. So let us take a system having g of s as a into s into h plus 3 plus or minus j4. Suppose if this is the power transfer function and h of s is 1, and if we consider a negative feedback, so we can locate the open loop poles at the origin, and the real part is minus 3, the imaginary part is plus j4 and minus j4. The intersection of these two will come over here. Now we know that of course let us only focus on what is the angle of departure, so let us not go to any other part. So angle of departure, to find the angle of departure theta t, we have an expression which is nothing but 180 degree plus phi. So this phi is nothing but summation of theta z minus summation of theta p. So what is this summation of theta z and theta p? So this summation of theta z is nothing but so okay, how do we fill all these things is, so we just join all uh, poles. Okay, if I want to find how does the root node set departs from this particular pole, so let me join this to this, and let me join this also to this. So I want to find this angle. Let me name it as theta p1. Let me name this angle as theta p2. Theta p2. Since I don't have any zeros, so this is now 0 minus. So this is actually theta p1 plus theta p2. Since I want to know this theta p1, so theta p1 can also be written as, so I can easily find what is this angle. This is actually 180 degree, and I can find this angle using the trigonometric rules. So now you can see this is a right angle triangle. I want to know this angle. We know that this angle, okay, some x degrees is nothing but tan inverse of opposite of this is actually 4 and adjacent is 3 magnitude. So it is 180 degree minus x degrees. So this is nothing but 180 degree minus this x degree is nothing but tan inverse of the opposite of this is actually 4 by 3. So this is my theta p1, which is nothing but I can actually find out how much is this angle. So it is now 180 minus tan inverse of 4 by 3. Make sure that it's in degrees. So you won't have it as 126.8 degrees. So this is theta p1. Theta p is theta p2 is straightforward. This is exactly opposite to that. On top of that, this is 90 degree. So this is a 90. This is 126.8. So naturally, this summation of theta p is nothing but 126.8 plus 90 degrees. So this will become 216.8 degree. This is the value of phi. This is the value, sorry, this is theta p. So that's then this phi becomes 0 minus 216.8 degree. So naturally theta d is actually 180 degree minus 216.8 degree. So which will be of course I think it is minus 36.8 degrees. Can you see here? So is this 180 minus 216.8 is actually minus 36.8. So this is theta. For this, how do we write? How do we? What is the significance of this? This is actually 0 degree line. So now this is 0 degree. So we know that minus 36 degree had to come down. So you approximately come down minus 36 degree, and suppose if this is the angle corresponding to 36 degree, which is the clockwise direction. This is now minus 36 degree. Now the root loci will actually depart like this. So this is how it is departing. So now I can say this is the angle of departure. So this is leaving at an angle of minus 36 degree. So since we know that root locus is always symmetric about real axis, if theta d of this is minus 36 degree, theta d of this will be always plus 36 degree. Meaning if this is 0 degree, then you can write approximately 36 degrees here, plus 36 degree, and root loci will actually leave in this direction. This is the angle of departure. This is how it departs. How it later goes, we'll discuss in some other time. So you'll have some asymptotes, something like this, and it actually goes along this, because you will know the point of intersection of this root loci with this image like this. Now we are only concentrating on how do we find the angle of departure. So angle of departure is minus 36 degree here. This need not to find, you can simply take it as plus 36 degree. Right? So this is how do you find the angle of departure of this particular problem. So let me take next one. That is G of S into H of S of a unity feedback system is K by S plus 1, maybe you can say S square, and S plus 4 plus or minus K2. Of course, this is the pole positions, poles and zeros position. Now I will write. So this is my repeating poles at origin. So there is a 0 at minus 1. The pole is at minus 4, and this is at plus J2 and minus J2. So naturally it comes over here. Correct? So this is my pole position. So I need to find theta D, angle of departure of this. For that, what I'll do, I will join all poles and zeros to this point. I will join this to this. I will join this to this. There are actually two here, and I'll join this to this. So now I will say this is theta P1 as well as theta P2, because there are two, theta P1 and theta P2. Let me say this is theta P3, and let me say this is theta Z1. Correct? So what is theta D? It is 180 degree plus phi. This phi is nothing but summation of theta Z minus summation of theta P. This Z you have only theta Z1 minus, here you have actually 3 theta P's, theta P1 plus theta P2 plus theta P3. So I know theta P1 is equal to theta P2 is equal to 180 degree. This is full 180 degree minus of this angle. How much is this angle? It is tan inverse of this opposite side is 2. This adjacent from here to it is 4. Okay. So now how much is this? It's actually 180 minus tan inverse of 0.5. So it is 153.4 degrees. What is theta P3? We know that it is 90 degree. This is theta P3, which is 90 degree. So overall, so what is theta Z? Theta Z1 you can write it as 180 degree minus tan inverse of opposite is 2. You can see this is unit 2. Adjacent is, here it is minus 4, here it is minus 1. So it's a unit 3. So this is now sorry 180 minus, sorry 180 minus tan inverse of 2 by 3. It is 158. It is 158.8. So it is now phi is equal to 158.8 minus of 153.4. 3.4 into 2 because there are two same plus of 90. So it is 158.8 minus of 153.4 into 2 plus 90 equals, so it is actually minus 238 degree. This is actually 5. So what is theta d? Theta d is equal to 180 degree plus 5, which is nothing but plus of 180 is actually minus 58 degree. So now the angle of departure of this particular pole is minus 58 degree. So how do you write it? So this is actually because this is 0 degree, minus 58 degree comes somewhere here. Okay, depending on how many asymptotes are there, it will be 3 asymptotes. You can find the so what happens, it departs at an angle of minus 58 degrees. So this angle is minus 58 degree. So whereas for this it will be plus 58 degree. It actually departs like this. So it is at an angle of plus 58 degree. Now depending on where is the centroid, okay, coming to this, where is the centroid? It's at minus 4, minus 4. That's it. And then minus of minus 1, it is plus by, it is 4 by 4 minus 1, 3. Is it not at minus 7 by 3? Minus 7 by 3 somewhere here. So 7 by 3 happens to be 2.33. It somewhere here, the it actually goes this way. You can find the angle of point at which half of the matrix is. Again, as I said, we are concentrating on only angle of departure. So this is theta d. It comes out to be minus 58. Okay. So let us consider one more. So let me consider g of s is equal to k into s into s plus 4, s plus 2 plus or minus j. So let me just consider a pole here, and there is a pole at this point. So again, theta d is nothing but 180 degree plus 5, where phi is nothing but summation of theta z minus summation theta p. So this is 0 because I don't have this, whereas summation theta p is nothing but now I need to join this to this. This is theta p1, this is theta p2, and this is theta p3. So this is the angle what you're supposed to find out. It is theta p1 plus theta p2 plus theta p3. So theta p1, as we know that it is 180 degree minus tan inverse of, so this is at j3. So height is 3, this distance is from here to here, this is the hypotenuse, this is the opposite, and theta p2 is 90 degree. And how about theta p1? This is actually, sorry, theta p3 is this angle. So this angle is straight away, it is tan inverse of how much is this? This is actually 3, and this difference is actually 2. So it is plus tan inverse of 3 by 2. You can actually see this and this will cancel out, and you will end up with plus 270 degree. See here, this is 180 degree minus tan inverse of 3 by 2. This is plus 90 degree for this, and this is again an angle of tan inverse of 3 by 2. This is minus, this is plus, we cancel out. This plus this is 270. So what is theta d now? Theta d is 180 degree minus 180 degree minus, so this will become minus of 270 degree. So this is minus 90 degree. So angle of departure is minus 90 degree, meaning that this pole will depart with this angle, which is minus 90 degree, and this will depart at an angle of plus 90 degree. So this is plus 90 degree. Okay. So this is departing like this. This is coming down, whereas this is going up. This is how you find the angle of departure of this particular complex pole. Let us do it for one more. QFS into HFS is equal to, let me just take, okay, this is K into S plus 2, S plus 3, this is okay, H plus 4, S plus 5 plus or minus J6, some random number. So I have this as my, this is my 0, another 0, there is a pole, there is a complex pole at this point, this is minus 5, and this is at plus J6, this is at minus J6. So you join all poles and zeros, this is 1, this is second, this is third, this is, sorry, this is this. So this is theta Z1, theta Z2, theta P1, this is theta P2. Right? Again, theta is nothing but 180 degree plus 5. 5 is nothing but summation of theta Z minus summation of theta P, which is nothing but, so you have theta Z1 plus theta Z2, and this is theta P1 plus theta P2. How much is this theta Z1? It is 180 degree minus tan inverse of, for this theta Z1, the height is 6, the difference is, here it is 5, here it is 2, the difference is 3. Here this is opposite to this angle. To this angle, the opposite is 6, the adjacent is from 3 from 2 to 5, which is 3. Again, this is theta Z1. So what is theta Z2? It is again 180 degree minus, this angle is tan inverse of 6 by 6 by 2, 6 by 2. This is theta Z2 minus of theta P1 is this 180 degree minus tan inverse of, this is unit 1 by 6, and this angle is plus 90 degree. This is theta P1. So let me find out what is this. So it is 180 minus tan inverse of 6 by 3. It's actually 153 plus, just approximating it, is 180 minus tan inverse of 3. It is 108.4 minus of 180 minus tan inverse of 6 inverse comma 6, it is 170.5 plus 90. Correct? So, so this is, the difference is 1, it is 6. So this angle is 180 minus, okay, let me just find out this. So this is, it is, I have a, okay, then it is 180 minus tan inverse of 1 by 6. Tan inverse of, sorry, this is 6 by 1. 6 by 1, sorry. So that's why I was just wondering, 180 minus tan inverse of 6, because that angle is very close to, this is around 99.4. So what is this? So it is now, it is 153 plus 108.4 minus of 99.4 plus 90 equals This is actually 72 degree is your phi value. So here it is 180 degree plus 72 degree plus 180 is 252 degrees. Meaning this is angle 0 degree, this is 180 degree, this is 270 degree. When you say 252 degree, theta d is 252 degrees. It comes somewhere here. It comes somewhere here. So now we can see this. Okay, as per this, of course, angle of departure. Since you are read about angle of departure, it departs at an angle of minus, sorry, plus 252 degrees. So here it is departing at an angle of minus 252. So minus 252 comes. This is minus 180, minus 270, minus 252 degree will be somewhere here. This is how this is angle of. Okay, this is about various angle of departures.